Okay, we are now in example 4. This is where it's getting a little bit more demanding of you. Remember that when we have a fractional exponent, to undo a fraction, we have to multiply by the reciprocal, right? Now, this isn't in your notes that you copied from Canvas, so you might want to just take an extra minute. But so we have to remember that the reciprocal of 5/2 is 2/5. So that's going to be our magical exponent that we're going to use. So we're going to have x squared plus 5x plus 5 to the 5/2 equals 1, and we're going to raise both sides to the 2/5. It should be a 2, peeps. 2/5. 2/5. So now these exponents right here cancel. And then 1 to the 2/5 is really nice. It's just 1. Don't you like how they gave us that really pretty number? And so then this side is x squared plus 5x plus 5. Then we're going to subtract 1 from both sides. We get x squared plus 5x plus 4 equals 0. So then x plus 4 times x plus 1, which means that x equals -4 or x equals -1. Then here again, you have to sub in your both solutions, the -4 and the 1. So I'm going to set, the one side is just, this side's just 1, so I really only have to plug it into one side. So we get -4 squared plus 5 times -4 plus 5 all to the 5/2. So we get 16 minus 20 plus 5, which is going to give us +1 to the 5/2, which is just 1. So that works. Then we're going to plug in our -1 solution. So -1 squared plus 5 times -1 plus 5 again. So we get 1 plus -5 plus 5, which just gives us 1. All of that should be raised to the 5/2. So we get 1, which is equal to 1. So that works. So in this case, we do have both solutions. All right, now B. Now we notice that this one is rational, but this one is a whole number. So you might say to yourself, what am I going to do this? Well, we're going to worry about getting rid of that rational one first, because if we get rid of the rational one, this one might take care of itself. So we're going to have x plus 18 to the 3/2 equals x minus 2 cubed. And we are going to raise this to the 2/3, our inverse of this. So I'm going to raise this side to the 2/3. So now what happens here, again, is we designed this so that these would cancel. So we just have x plus 18 over here. And then over here, you've got 3, or 3 over 1, times 2/3. Well, when we multiply that, we just get 2. So we have x minus 2 squared. So now, remember, we have to FOIL here. So x minus 2 times x minus 2. So we have x plus 18 equals x squared minus 4x plus 4. And again, we have to move everything over. The process from this point is the same. So we get 0 equals x squared minus 5x minus 14. We'll do our factoring, and we get x minus 7, x plus 2. So now x equals 7 or x equals -2. And then our last little thing is, do they work? Now, in my notes, I had to scribble a bunch of stuff out, so it's a little messier, but hopefully I can make this work for you. So we're going to plug them in. So we get x minus 8. Oh, we want to make this 7, sorry. So we're going to get 7 minus 18 to the 3/2 equals 7 minus 2 cubed. So 7 minus 18 is going to be -11 to the 3/2 equals 5 cubed. So now, again, the easier way to do this actually is to plug these, hold on. What was I doing? Oh, I just wrote plug them back in, and -2 doesn't work. So really, like, you don't have to go through all of this. Just put it in your calculator, see what you get. Use your calculator to plug them in. And you get that 7 is a yes, and -2 is a strong no. And there we have it. Okay, let's go on to example 5. Example 5 also takes a lot of work because we now have 2 radicals. So when you have 2 radicals, you want to first identify which one the more complex radical. In this case, it's that x plus 9. So that's the one that we want to get by itself. So we're going to go x plus 9 minus square root 2x equals 3. So this one is more complex because it has addition inside the radical. This one just has simple multiplication. And so when we move that over and we square it and do things with it, it becomes a lot easier to deal with. So I'm going to add the square root of 2x to both sides. So we get the square root of x plus 9 equals 3 plus the square root of 2x. And then from here, the steps are pretty much the same. We square both sides, right? So that means we get, whoops, not a square root there because they cancel. So x plus 9 equals, and then this part becomes 9 plus 6 square root of 2x plus 2x. So now here again, we have a radical. You know, it's kind of embedded in there. So you're probably thinking, oh crap, what do I do now? Well, we can solve quadratics and we don't have a quadratic. So we're going to make this a quadratic by getting this by itself. Get this one alone. So we're going to subtract 2x from both sides. And we're going to subtract 9 from both sides. So now, oh goodness sakes, this gets really easy because now we just have negative x, because those cancel out everywhere, equals 6 square root 2x. And then what we want to do here is just square both sides. Because this 6, even though it's out in front, remember that it doesn't do weird things like addition and subtraction do. So we can leave that 6 out there. And by squaring both sides, we're getting rid of this negative. So we're going to get x squared equals 36 times 2x. And x squared equals 72x. X squared minus 72x equals 0. I pull an x out, x minus 72. So x is equal to 0, or x equals 72. And then again, you plug those into your calculator, and 72 does not work, but 0 does. So this is our only answer that works. So now